Our topic today is variation, and there are several types. There's direct variation, which has the form y equals kx, inverse variation, which has the form y equals k over x, joint variation, which has the form k xz, and combined variation, which is a combination of direct and inverse, or joint and inverse, and it has the form y equals kx over z. Now this k is called the constant of proportionality. That is not a variable. We'll have to determine what k is given values for the variables. And then when we install that value of k into the structure of the equation, we will have the general formula to describe the variation. So also, how do we know which type of variation to use? Well, that will be defined within the context, or stated within the context of the problem. So here's our first problem. We have to write the general formula to describe the variation of y varies directly with x. So varies directly. We're talking direct variation. So it's going to have the form y equals kx. Next, they've given us a value for y and a value for x. And with those two values, and let's take our original equation and solve for k, and if we solve for k, we'll divide through by x, and now we know y equals k over x, k equals y over x, beg your pardon. And so k equals, and substituting 2 for y and 10 for x, we have k equals, and that reduces to 1/5, and now we can write the general form to describe the variation, and that's y equals 1/5 x, and we're done. Well, this time we have to write the general formula to describe the variation z varies directly with the sum of the squares of x and y. So again, they told us what type of variation we need to use. So z equals k, the constant of proportionality, times the sum of the squares of x and y, x squared plus y squared. And they also told us that z equals 5 when x equals 3 and y equals 4. Now, let's take this equation and solve for k. So k equals z over x squared plus y squared. Because our task here is to find k. When we find the value of k, we'll install it for k in this position, and then we'll be done. We will have the general formula to describe this variation. So k equals, z is 5. X is 3. Well, we have to square 3 and we'll get 9. Y is 4. We have to square 4 and we'll get 16. So k equals 5 over 9 plus 16 is 25, and that reduces to 1/5. So now we can write the general formula to describe the variation, and we get z equals 1/5 times the sum of the squares, x squared plus y squared, and we are done. Now we are to write a general formula to describe the variation. The square of t varies directly with the cube of a and inversely with the square of d. So they told us what type of variations to use. So t squared equals constant of proportionality k times, and directly with the cube of a, so that's a cubed, and inversely with the square of d, d squared. Now, this is a form of combined variation. We combined direct variation with inverse variation. Now, t equals 2 when a equals 2 and d equals 4. Our next task is to isolate k, given this equation. And so k equals t squared, and if we multiply both sides of this equation by d squared, this d squared will divide out, and we'll have d squared times t squared on the other side. If we divide both sides by a cubed, this a cubed will divide out, and on the other side we will have the denominator a cubed. Now we'll substitute the appropriate values and come up with a value for k. So t squared, if we square 2, we get 4. D squared, if we square 4, we get 16. And a cubed, if we cube 2, we get 8. And 8 goes into 16 twice, so k equals 4 times 2, which is 8. Now we can replace k in this equation with 8, and we will have the general formula for the variation. So t squared equals, replacing k with 8, and upstairs we have a cubed, and downstairs we have d squared, and we are done.